All right, so our first example for a matched paired t-test would be it says a politician asks his staff to determine whether the underemployment rate in the Northeast decreased from 2011 to 2012. Test the claim at the 5% significance level, and the results are as follows. So I have the northeastern states. It tells me what they are, and then a time point, right, the unemployment rates in 2011 and 2012. So they're wanting us, right, did it decrease from 2011 to 2012? So we want to determine and actually state what we're going to make X1 and X2. So X1 is going to represent 2012 and X2 is 2011, so that the difference here, right, of X1 minus X2, we're looking at 2012 minus 2011, right? And if I think if it decreased, right, from 2011 to 2012, in general, 2011 should have the larger number, right, larger, and 2012 should have a smaller number. So the overall difference, if this is true, should be negative, right? Overall difference would be negative. And we go through this because this is going to help us determine the type of hypothesis test that we're going to do. So I'm going to first start by saying, right, that we're saying there's no difference between the means. In my alternative, since we're saying it's, right, we want an overall difference of negative, it's going to be less than 0, right? We're saying less than 0 for the overall difference in the between the 2 years. Okay. So what I want to do and what I'm going to have my calculator do is actually find the differences here, and it'll store it here. So since we said X1 was 2012, we're going to type in this data into L1, and 2011 is going to be L2. Okay, so if I go, I'm going to hit my stat button and edit, and you may have some data in here from before, so we'll just arrow up, clear anything out that you have. And now we're going to go through and enter this data into my calculator. So remember, we want L1, right, for 2012. So I'll enter this in here, and we'll hit enter after each piece of data. All right, so I'm going to pause the video at this point, and I'm going to enter this into my calculator. You can pause the video here and do the same, and then I'll be back in just a minute. All right, so now I have all the data entered into my calculator. Now, if you look just to see, right, the 15.5, the 17.3, you can see that in our table as well. So they should match up, right, because we're looking at matched pairs. Okay, so before we move off this screen, what we need the calculator to do is calculate the difference. So I'm going to arrow over, and I'm going to arrow up so L3 is highlighted. So what I'm going to tell the calculator to do is find the differences between these lists. So I'm going to hit second, and I'm going to hit number 1. So that's going to say I'm going to take L1 minus, and I'm going to hit L2. So second and number 2. And if I hit enter, it will calculate the differences for me. So, 16.4 minus 17.9, that is negative 0.9. And they did that for all of these here. So you can see, right, that a lot of them have a negative difference, not all of them. And so what we're going to look at is it statistically different, right, significantly enough far apart. If you got an error, just make sure that when you're hitting those L1s minus L2, that it's up highlighted in L3. If you try to do it underneath one of these pieces here, it'll give you an error. Okay, so I have this data. It's going to store this for me. We're now going to hit our stat button. We're going to go over to test, and we want just a t-test, so a single t-test, since we've combined the data into that difference list. Okay, so we do have the data, so we're going to enter data and hit enter. Now, mu naught, right, this is what we're saying. We're saying that there's no difference. My list, right, we want L3. We want the differences. We don't just want, right, just one of the years. So how I get L3 is hit second and then number 3. frequency will leave as 1. In this case, we have less than for our choices here, and we will calculate it. Okay. So let's take a look at what the calculator gives us, right? It gives us our test statistic. So t is negative 1.23. Now it says, right, my p-value is 0.121. Now it does say x bar, but in our case, right, x bar sub d, right, is the differences, or, and so you could say is negative 0.6. And the standard deviation, right, of the differences looks like it's roughly 1.76. So the calculator does give you this information here. It's just not quite the variables that we want, but it's the same pieces of information. Okay, so really the biggest thing is the p-value, right? So I compare my p-value with my alpha, right, significance level of 0.05. We notice the p-value is larger, so we are going to fail to reject. So we could say at the 5% level of significance, there is not, right, because we're failing to reject, is not sufficient evidence to, right, so it says whether the underemployment rate in the North has decreased. So there's not enough sufficient evidence to suggest the underemployment rate in the Northeast decreased from 2011 to 2012, right? So, you know, it did look like we did see some negative differences, but it doesn't look like it's statistically significant. So here is our example of when the samples, right, are dependent and how we go through and do a t-test for this one.